Hello, everyone. Welcome to the Math Magician's Den. This is the Herm Dog. We're going to talk about some properties for logarithms. And since I'm putting this in my calculus folder, I want to show you later on how some of these would be very helpful for calculus. Now, first of all, what is a logarithm? If y equals b to the x, then log base b of y equals x. So what do we mean by that? Well, you guys know that 2 to the third is, well, 8. So the corresponding logarithm would be log base 2. It has the same base as the exponential. The answer to the exponential goes inside the logarithm here. And the answer to the logarithm is the exponent. So that's how logarithms work. Now, the other thing we have to remember about logarithms is this. When you look at the base has to be bigger than 0. Because if we take negative numbers to a power, it's going to cause us a lot of headaches. Also, if I take 0 to a power, it's always 0, so that's not really an exponential. It's the same thing with b equals 1. 1 to any power is just 1, so it's not really an exponential. So when we talk about logarithms, it's the same thing. Also, when we talk about logarithms, there's a few things I want you to know. Y equals b to the x and y equals log base b of x, these two are both functions. In fact, they're both one-to-one functions, and they're inverse functions. So what do we do when we talk about inverse functions? Well, with inverse functions, you switch x and y. Okay? You switch x and y. And then if you solve for y, if you switch the x and y here and you solve for y, you're going to get a logarithm. So we know the domain of an exponential is all reals. Well, that should be the range of the logarithm. The domain of a logarithm is going to be 0 to infinity because the range of the exponential was 0 to infinity. They switch because we switch x's and y's. And the graph of an exponential has an asymptote y equals 0. So a logarithm would have an asymptote at x equals 0. And if you take a look at these two graphs, and we're going to take a look at them on Desmos here, the red graph is 2 to the x. The blue graph is log base 2 of x. So these are a logarithm and an exponential with the same base. You'll notice that they are mirror images through that green line, y equals x. Also notice the red graph levels off at the x-axis at y equals 0. That's its asymptote, which means the blue graph will get closer and closer to x equals 0, the y-axis. That's its asymptote. And I've put a couple of select points on these two graphs. The red graph, you've got 0, 1. Take a look at the blue graph. You've got 1, 0. The red graph, the exponential, you've got 1, 2. 2 to the first power is 2. Well, log base 2 of 2 is 1. You'll notice whatever point lies on the red graph, its corresponding point, switch the coordinates around, will lie on the blue graph. This point right here is 2, 4. So what point should lie on the logarithm? You got it. 4, 2. Works every time. Now, a couple other things about logarithms that you need to know, okay? With logarithms, if you see ln of x, the natural log of x, that is basically a base e logarithm. As a math teacher, I would never write this, even though it's correct. I write the natural log of x. It's a lot easier. If you don't see a base, the base is 10. And one really important aspect of logarithms is the change of base formula. If you want to evaluate log base b of x, with some of the older calculators, you're going to need this. It's the natural log of x over the natural log of b. And you can try it if you'd like, okay? Take your graphing calculator out, maybe pause this video and try to take log base 2 of 9. Now, I know that 2 to the third power is 8, so then I know that this number is going to be a little bit bigger than 3. And here's the thing. If I take the natural log of 9 and I divide by the natural log of 2 on my calculator, I'm going to get about 3.1699, and there's a lot more decimal places after that. Try it with the common logarithm. Take log of 9 divided by log of 2, and you're going to get the same thing. The fact is, you can use any base that you want. You can change it to any base, okay? And it's going to work. It's going to give you the actual answer. Now, some other rules for logarithms that everybody in calculus is going to need to know. In fact, in pre-calc, you're going to need to know it. At the end of Algebra 2, you may be taught this. If you multiply two expressions inside a logarithm, you can add their separate logarithms. Now, you might be thinking, well, why is that? Well, remember, the answer to a logarithm is an exponential, or is an exponent. What do we do when we multiply? We add exponents. So if you take log base 2, sorry, my pen's not working here. Let me change this a little bit. If I put x times w, this would be log base 2 of x plus log base 2 of w. Now, if you see division, what happens when you divide? You subtract logarithms. So if I put log base 3 of 7 over x, that would be log base 3 of 7 minus log base 3 of x. And there's one more that's really important for calculus especially. If you have an exponent inside your logarithm, you can bring that exponent out front and multiply. Because if you raise a power to another power, you multiply the powers. That's why this rule works. So if you have log base 7 of x to the 6th, you can bring that 6 out front, 6 times log base 7 of x. Those are rules for logarithms that come in really handy when we're doing calculus. A couple other things. Y is log base b of 1 equal to 0? Because b to the 0 is 1. Why is log base b of b equal to 1? Because b to the first power is b. Now, these next two, I think, are obvious because of our rule for inverses. But a couple of reasons here. B to the x equals b to the x. That's one reason this works. Another reason, you could bring that x out in front using the rule we just stated above, and this would be x times 1, which would equal x. The last reason that I really like is that b to a power and log base b are inverses. They would cancel and give me x. They're inverses. Both of these, I end up with x because I have inverses. B to the log base b of 4, that would equal 4. Log base 8 of 8 to the 5th, that would be 5. That's how both of those formulas work. Now, because they're logarithms, all of these work for natural logarithms as well. Okay? So if I have, and I'll write it up here, the natural log of 4x. This would be the natural log of 4 plus the natural log of x. If you had the natural log of y divided by e, this would be the natural log of y minus the natural log of e. Same thing if you had the natural log of x to the 7th. You could bring that 7 out front. Now, what is a natural log? It's base e. So when you're looking at this, e to the 0 equals 1. That's why this logarithm equals 0. This one, the base is e to the first equals the e that's inside. E to the first is e. And again, these next couple of questions here, this x right here, the natural log is base e. This exponential is base e. They cancel and just give me x. Or I can bring the x out front, and it's x times 1, which equals x. The next problem, e is the base of the exponential. e is the base of that logarithm. They cancel because they're inverses, and they give me x. As a matter of fact, if you look at the top of the screen, this problem right here, this is the natural log of y minus, what is the natural log of e? It's 1. So you notice how some of these properties can help us simplify logarithms. Now, let's test you a little bit. What if I had the natural log of e to the second times x squared divided by y cubed? When we write this as simpler logarithms, this is called expanding. How do I expand this? Well, first of all, I'm going to write the natural log of e squared. There is multiplication, so I put a plus. Then I'm going to put the natural log of x squared because it's multiplied on the top. And then since this is divided, I'm going to put minus the natural log of y cubed. That is our product rule, turns into addition. That is our quotient rule that turns into subtraction. But then those exponents, I could put the exponent out front. I could put the exponent out front. I could put the exponent out front. And then would you believe we're still not done? What's the natural log of e? That's 1. So this would be 2 plus 2 natural log of x minus 3 natural log of y. That, when you go from one logarithm to many logarithms, many simpler logarithms, this is called expanding. If you were to actually go backwards, this is called condensing. And those are both useful for us. Condensing is useful for solving equations that involve logarithms. Expanding is going to be very helpful in calculus in terms of taking derivatives and even sometimes integration. If you like this video, please feel free to hit the like button. Feel free to subscribe to my channel. I'll be posting more videos as time goes by.